Hello everyone, welcome to OneClass. My name is Shanjida and today I'll be going over some commonly asked math questions both at the high school / university and college levels. And so currently I am a second year human biology student. And lastly, if anyone needs additional schoolwork help or needs tutoring, you guys could check out the description box below. And other than that, we'll get started. And so the first question for today says, what is the square root of 84? So we're trying to find out what this equals to. So square root of 84 is equal to what? And so what we want to do, the simplest way to do this is to basically express the number 84 as a product with one of the factors as a perfect square. So let's say 84, okay, and let's express this. So this would be a product, so we have to find two numbers that when you multiply it will give you 84. So let's say in this case, let's say 21 times 4. Okay, and so we can further break down 21, or actually since 21 won't give us even numbers once you break it down, so we'll just leave it like that. However, 4 will, so you have 2 times 2. And so what we're going to do is we will express our 3 factors or 2 factors under a square root. And so what we're going to do, we have square root of 84 is equal to the square root of 21 times 2 times 2. So you have square root of 21, and I'm going to pair the 2's together. So we have times 2 squared. You guys probably know that if there's a square, the square root will cancel. So both of the operations will cancel out. So we would still have square root of 21. However, we would also have 2. So our answer in simplified form would be 2 square root of 21. And so the square root of 84 is equal to 2 square root of 21. Okay, correct it. 2 square root of 21. Okay, and so this is what the solution is correct. Okay, so our next question says, how do you find the exact values of cotangent of 45? So let's write this down. Cotangent of 45. And we're supposed to find cosecant of 45 and secant of 45. So we're supposed to find what the exact values are. And so what we're gonna use are the formulas that need to be used are trigonometric reciprocal identities. So if you guys recall that let's say cotangent of x, okay, let's say cotangent of x is the reciprocal of tangent x, or tangent, right? And so then we have, so let's say cosecant of x is the reciprocal of sine x. Right, so this would be 1 over sine of x. Right, and lastly, what we have secant. We have secant of x. So secant is the reciprocal of cos of x. So this is 1 over cos of x. So keeping these properties in mind, the solution for this would be to basically draw out so since we're dealing with 45 degrees, you know that this is a special triangle. So we're dealing with special angle triangles, and so draw out a triangle, right angle triangle. Okay, 45, and this is also 45. And so we can now say that if you guys recall that our hypotenuse is equal to square root of 2, and our sides are equal to 1. And so let's further now evaluate sine, cos, and tan of 3 ratios. So we can say cos, let's say cos of 45. You guys recall the ratios, or the ratio is adjacent over hypotenuse. And this, so we're looking, let's say, at this angle right here. So adjacent would be 1, and our hypotenuse is square root of 2. And so what we have here, so this is basically the same thing as square root of 2 over 2. Okay, to simplify it, and then let's now find sine of 45, which is the ratio of opposite over hypotenuse. And so we're still looking at the bottom angle of 45. The opposite is 1, and hypotenuse is square root of 2. So this is also square root of 2 over 2. Lastly, we'll look at tan of 45. This is opposite over adjacent, and opposite is 1, and adjacent is also 1, so this is basically just 1. Okay, since we found out our values for each of the 3 trigonometric functions, we can now find the reciprocal of them. Okay, so what we can say now that cotangent, or let's say cosecant, now say cosecant of 45 is equal to 1, the reciprocal of cos of 45. And we know that this would equal 1 over our cos value, which is square root of 2 over 2, so it's going to be square root of 2 over 2. And we get, so we basically have to turn this over, so it's 1. It would be 2 over square root. Next one, let's say secant. We have secant of 45. This is equal to the reciprocal of sine of 45. So this is 1 over our sine value that we got, which was square root of 2 over 2. So this would be square root of 2 over 2. This is also equal to 2 over square root of 2. Okay, so you're just doing the reciprocal. And lastly, we're looking at cotangent of 45. This is equal to 1 over tan 45. And so this is 1 over, so tan of 45 was just 1. And so we have 1 over 1, so it's just 1. Okay. So these are your ratios. And now what we have to do, we can, so these are your, so this is basically your, this is basically our answer, that cotangent of 45 is equal to 1. Cosecant and secant of 45 is 2 over square root of 2. However, we can also rationalize so that we can get, we can basically, what I mean by this, so for cosecant of 45 and secant of 45, we can simplify, further. What I mean by that is that we know that both of them are 2 over square root of 2. We can basically rationalize this by multiplying the top and the bottom by square root of 2. And so you would basically get, 2 square root of 2 over 2. And so what you basically get is, okay? And so therefore we can say cotangent of 45 is equal to 1. Cosecant of 45 equal to square root of 2. Secant of 45 degrees is also square root of 2. So this is your answer. And let's see this. Our next question says, what is an obtuse angle? So an obtuse angle, is an angle which is greater than 90 degrees, which is a right angle, right? So it's bigger than a right angle. but less than 180 degrees. Okay, so it's basically, so let's say you have a right angle triangle or right angle, and your obtuse would be something that's bigger than that, so it'd be like, it would be this, it would be, sorry, so it would basically be this whole angle right here. Okay. It would be something like that. So it's bigger than it's bigger than 90 degrees and less than 180. We can say that obtuse angle is greater than 90 or less than 180. We can write the angle for an obtuse. Obtuse angle is within the range of 90 . Okay. So and so the next question that we have is how do you simplify square root of 250? Well, let's square root 250. And what we're gonna do is express this as, so like 250 as a product. We have 250, and we're gonna find multiples of it until we reach the end. So like we reach the lowest multiple or the smallest multiple, and so let's say 250 divided by 250 divided by 50. So we can have 250 divided by 50 would give you 5. And so you can break down 50 even further. So you have 25 times 3. And you can break down 25 even more, which is 5 times 5. Okay. And so in this case, you can see our lowest terms are 5, 2, 5, and 2. And so we're going to express all of these under a square root. So you have square root of 250 is equal to the square root of 5 times 5, 5 times 2. And I'm going to pair up the 5 So then we have, so we're going to pair up these two. And we would have 5 squared times 5 times 2. And as you can see, we have a square under a square root, so that will get cancelled out. And so you're left with, you're basically left with 5 square root of 5 times 2. And so 5 times 2 is 10, so you have square root of 10. Okay, so we can say the square root of 250 is equal to 5 square root of 10. And next question says, what is the square root of 216? So let's say the square root of 216. So we're gonna express express 216 as a product. So we would have, let's say 216. Okay, we're gonna find the multiples until we get the lowest or the smallest term. So let's say 216 divided by 300. Let's say 216 divided by 6. So we have 36. 6. So we can further simplify 36 and 6 to get 2 times 3. 6, 6. So we have 2 times 3 and 2 times 3, right? So our lowest term, or the lowest factor in this case, are 2 and 3. So we would group these and put it under a square root. So you have square root of 216, which is equal to the square root of 3 times 3 times 3 times 3 times 3. Now what I'm going to do is group them, group the 2's into pairs and the 3's into pairs. So we would group, I would group these two together and these two together, and you would have an extra 2 and an extra 3 remaining under the square root. So once I pair it up, we would get 2 squared 2 times 3 squared times 3 squared times 3. Okay? And so we know that the square, since there's a square under a square root, they will both cancel out. So you're left with, so you have 2 times 3 and a remaining of 2 times 3. Okay? So we can multiply the term outside the square root, which would be 6, and multiply the term inside the square root, which would also be 6. And so, since we can't further simplify this, our answer is 6 square root of 6. So this question. It says, how do you prove sine of a plus b times sine a minus b? So we're trying to find what this whole equation is equal to. Okay, so we're trying to figure out what this would equal to. So we have sine of a plus b times sine of a minus b, which is equal to sine squared a b minus sine squared of b. Right? Okay, so we're trying to basically prove the given equation that the left hand equals the right side. So what we need to do is we're going to use the sum and difference identities so that we know. So the formula for the differences for the first part we have, so the formula for the sum and difference identities, we know that for, let's say that using the sum and differences identity. Identity. So we know that sine a plus b is equal to sine a times cos of b plus cos of a times sine of b. Right? And so the difference is one would be sine of a minus b, right? And so this one would be sine of a times cos of b. So only the operations would change, the signs in this case. So this would be negative or minus cos of a sine of multiplied by sine of b. Okay? So these are your two formulas. And so what we're gonna do, we're gonna substitute our sums and differences into the equation. Okay, so we're gonna say substituting. So that we get, oops, so that we get, so this would equal to, so we're substituting it back into our equation. Where there's a sine a plus b, we would write that with our identity equation. So what we got out of our identity equation, and for the same thing that goes with sine a minus b. So for sine a plus b, we got sine of a times cos of b. Obvious. So in this case, we have, so for sine a plus b, we have sine of a cos of b plus cos of a sine of b. Right? And so this is for the first part. And so now what we're going to do, since it's a multiplication with sine a minus b, we would basically multiply this with our minus equation, our difference equation, which is sine a by, we multiply this by sine a times cos b minus cos a sine b sine, right? And so as you can see, we just substituted this into our equation. So we got this full equation right here. And what we're going to do, we can now, basically using algebra, we can see that this whole thing is, so using algebra, we can see that this kind of resembles a plus b times a minus b, which is equal to a squared minus b squared. And so what we can basically say that we can let, so what we can say is that we'll let this case, let a equal sine of a cos of b, and that b equals cos a times sine a. And so simplifying, so let's simplify. Okay, so we have, so this would equal to basically, so we would just write a plus b minus, or a squared minus b squared, right? So we're going to write that in terms of cos a and in terms of cos and sine. So you would get sine a squared, which is sine a times cos b, a times b squared minus b squared, which is cos a times sine b of cos a times sine b squared, right? So then we can break this up. We can further evaluate this, and we would get sine squared a cos squared of b minus cos squared of a sine squared of b. Okay. And now using the Pythagorean theorem, we can also use another identity. So using Pythagorean identity, we know that sine squared of a, or we know this one, let's say x, plus cos squared of x equal to 1. And so we can rearrange this to find sine of x and cos of x. So we get, so from this we can say that sine squared x is equal to 1 minus cos squared of x, and we can also say that cos squared is equal to 1 minus sine squared of x. Right? And so substituting this, we can get, so substituting from the identity, the Pythagorean identity, so we get, so where there's a cos square, we would substitute that with, so we want to do, the substituting where cos squared of a, or let's say a or b, we're gonna replace that with 1 minus sine squared of a or b. Okay? So we're gonna write this whole equation in terms of sine, and so what we get sine squared of a times 1 minus sine squared of b minus sine squared of b times 1 minus sine squared of a. Okay. And so what we have, so we can just further simplify this. And we would get, what we would get, sine squared a minus sine squared b minus sine squared a times sine squared of b. Right, so I'm just distributing this, and then we get plus sine squared b sine squared of. Okay, so I just distributed this as well. Okay, just use FOIL, and then what we get, so this whole thing, once you simplify it, you will get sine squared a minus sine squared b. Okay, so you can see what we can cancel out. So in this case, we're canceling out, we know that this and this will cancel out, right, since it's minus and a plus. And so you're just left with sine squared a minus sine squared b. And so therefore, we just let the left-hand side equal the right-hand side, or probably restate this and say, so we can say the sine of a, so our original equation, which was sine of a plus b times sine a minus b is equal to sine squared a minus sine squared of b. So we just proved this, and therefore we can say, that the left side is equal to the right side. And so, so the solution is number 7. Our next question says, what is the formula for the surface area of a triangular prism? Okay. So given this triangular prism below, we can say that the surface area can be denoted as surface we can say surface. So we're trying to find out the surface area of this triangular prism. And we can say that the surface area, so you can see we have a base, we have a height, we have a length, and we have a side length. Okay. And so we can express this as SA, upper surface area of a triangular prism. SA, so we can basically write this. So since this area, we know that it would be multiplication and addition, and so the formula is basically derived from the base times the height plus the length, which is, you can see over here, and so plus your 2 times length and the side. So in this case, we know that there's 2 sides here, 2 length, you have a base, and you have a height, right? And so we can basically further simplify this, and we would get plus 3 times length plus 2L. Right, so I just FOIL this out. And so this is what you get for your surface area. So basically the formula of the surface area of a triangular prism is given by this formula, where SA is the surface area, B is the base of the triangular face, right? So B is this whole base, and H is the height of the triangular face, L is the length of the lateral edge right here, and S is the length of the triangular edge. So you can say this is the slant height. Okay, and so basically this is your formula. So this is all right. Question says, what is 3 pi or pi over 3 radians in degrees? Okay, so we can convert radians into degrees or vice versa using the following conversion factor. So the conversion factor is so 1 radian or 1 rad is equal to 180 degrees over pi. So we're going to convert now. So now converting. We're converting. So we have pi over 3 radian times 180 degrees over pi. And so from this, you can see that pi is pi radian. Okay, so we would get, so those would get canceled out. So you have 180, you'd get 180 divided by 3, and so this is 60 degrees. And so we can say that pi over 3 is equivalent or is equal to 60 degrees. So this is correct. Okay, so our next question says, what is the area of a semicircle? Okay, so let us draw a semicircle. Semicircle is basically half of a circle. But yeah, so this is your circle, your semicircle would be half a circle. And so this is basically saying, okay, so this is our semicircle. If you guys recall that the area of a circle is given by, so the area of a circle is pi r squared, where r is your radius. And so we know that the radius is half the distance across the circle, or distance of the circle. And so since you can see from this picture that since it's half of the circle, we can assume that the area of a semicircle is also half of the formula of a circle. So we can say, since a semicircle is half of a circle, the area would also be half of the area of a circle. Okay, so basically what we would have, since this area of a circle is pi r squared, the area of a semicircle would be divided by 2, and so this is pi r squared over 2. Area of a semicircle. And so yeah, this is yeah. Next question says, what is cosecant of 0 equal to? Okay, so now to find the value of, so let's say, so we're trying to find out what ratio or what it is equal to. And so to find the value of cosecant of 0, we use a trigonometric function that, if you guys recall, that cosecant of, let's say, x is equal to the reciprocal of sine of x, right? And so we can basically substitute 0 for sine of x also. So we get cosecant of 0 is also equal to the reciprocal of sine of 0. And we know that sine of 0 is 0, so we say 1 of 0. And this is basically 1 divided by 0, or anything divided by 0 is undefined. Okay, so we can say that cosecant of 0 is, or it does not exist. Okay, so our next question says simplify expressions with rational exponents. So we basically have to find which one of them would simplify and which one. So we are given the options here, and we're supposed to figure out which one it resembles. So given this expression where we have p, we have p to the power of negative 3 over 4 times q to the power of 3 over, so this is all to the power of 1/3. So we have p minus 2 q to the power of 4 times p squared times q to the power of 4 of 1. And so we're given 4 options here, and we're supposed to see which of them it's correct. And so to evaluate this, we need to basically use the laws of exponent. So we'll use the law of exponent, where x to the power of m to the power of n is equal to x times x to the power of m times n. Okay? And so to do that, we're going to now simplify the numerator and the denominator, and we're going to write, so this will then equal to basically p to the power of negative 3 over 4 times 1 over 3 times q to the power of 3 times 1 over 3. Okay? And then for the denominator, we're going to have p times negative 2 q, or p to the power negative 2 q to the power 4, and we're gonna have, for this, then we're gonna have times p to the power of 2 times a half times q to the power of 4 times a half. Okay, so we can see that we have this, and so Then we're going to multiply the exponents accordingly. So from this, we can see that our 3's would get cancelled, right? So 3's would get cancelled here. Our 2's, and this would be 8, 2, right? And so we can further simplify this, and we would get e to the power of negative 1 over 4 times q to the power of 1 all over p to the power negative 2 to the power of 4 times p power of 1 times q to the power of 2. Okay. Now we're going to apply the negative exponent rule. So apply negative exponent rule. So this is where you have negative exponents. So we have x to the power of negative n, where y is negative m. So this is y to the power of m over x to the power of n. So you just flip the numerator and the denominator. And so what we have, so you can see we have a negative on the top and negative in the bottom from our equation. So we can say, that to the power, so over here, since we have p to the power negative 1 over 4, right, we're going to express, so let me write that down, p to the power of negative 1 over 4 times q to the power of 1 over p to the power negative 2 q to the 4, right? And this is multiplied into p to the power of 1 times q to the power of 2. And now what we're going to do, we're going to simplify this, apply, we're going to now take the reciprocal of this, and we're going to have a new equation would be p squared times q to the power of 1 over p 1 over 4 times q to the 4 times p 1 times q squared. Okay. Now we're going to apply the product rule for the same base. If you guys remember, apply product rule. With same base. So this is where you have a to the power of m times a to the power of n, and this is going to be a m plus n. So we're going to use this formula and apply it. So then what we get is, so let me write out the equation. So we have p squared times q power of 1. We have p 1 over 4. And so we're going to put all the like terms here, and then we have q to the 4 times q squared. Okay, and so next what we have, we have we're gonna apply the product rule for the denominator. So we have p squared times, so q to the power of 1 is just q, so just write q. So p plus 1, so it would be p 1 over 4 plus 1 times q to the power of 4 plus 2. Okay. And what we have, so p squared q over, we get p. So we would just use for the p, we would have a common denominator of 4. We have 5 over 4, a fraction, times q to the 6. Okay. Now what we're going to do, we're going to apply the quotient rule. As you can see, we're dividing. In this case, so you could see that we're dividing p squared by p to the power of 5 over 4 and q divided by q to the power 6. So what we're going to do, we're going to apply quotient rule. Where you guys recall that it is, quotient rule states a to the power of n over a power of m. So it's basically a is basically a n minus. Okay, so we're going to apply this rule, and we get, so what we have here, I'm going to do p 2 minus 5 over 2 times q 1 minus 6. Okay? And so from this, we have p 3 over 4 times q to the power negative 5. So you can see we have a negative exponent, so we're going to use the negative exponent rule, and we're going to get p 3/4, and the negative would go to the denominator, so that p to the power 5. And so this, so basically this is our answer. It's going to be q to the power. Okay. So basically this is our answer. This is how you simplify. And let's see which one of the options it matches. You can see that the answer is D. Right? Yeah. So and so basically that was the end of our session. If you like this Q&A, please subscribe to the OneClass channel, like, comment on this video, share with your friends, and if anyone has personal one-on-one questions or needs tutoring, you guys can check out the link and follow the link and ask your questions. Other than that, I'm Shanjida, and I hope to see you guys soon. Bye-bye.